The title of the project is Remedial Measure to Avoid Cracking of Center Pivot Cross Structure in WAP-4 AC LOCO. This project was done by S. Anandasagar, U. Balachandran, M. Praveen Kumar. The internal guide is Mr. P. Karthikeyan, Assistant Professor, Vailtech Engineering College. External guide is Mr. D. Sridharan, SSC Inspection, Perambur LOCO Works. This project was carried out in AC LOCO section of Perambur LOCO Works, Southern Railway. By designing and analyzing various models of center pivot cross structure design, the effect of cracking in center pivot cross structure can be eliminated. Among the various activities carried out in AC LOCO section, replacement of center pivot cross structure is one of the most important activities. The safety and performance of AC locomotives highly depend on the conditions of the center pivot in high-speed locos like WAP-4 class of locomotives. Due to ever increasing demand for transport and to reduce overhauling time and expenses, the importance of proper care is required during the replacement of center pivot.
This is the basic structure of a locomotive. This is a basic locomotive body and it rests on two bogies as shown in this figure. The bogies are of LOCO type, which means the bogies has three axles as shown in this figure. The primary suspension is provided between the axle and the bogie frame. The secondary suspension is provided between the bogie frame and the bolster frame. The center pivot of a locomotive body rests on the bolster frame. This is the center pivot bowl present in the bolster frame. This is WAP-4 center pivot. This is WAM-4 center pivot and this is WAG-7 center pivot.
This is the WAM-4 AC locomotive. W means wider, A means alternating current and M means mixed traffic. The WAM-4 AC locomotive body mounts on two tri-mount bogies as shown in this figure. Each tri-mount bogie has one center pivot and two loading pads. The center pivot carries a vertical load up to 30% and each loading pad carries a vertical load of 10%. This type of bogie is having only a primary suspension. It doesn't have a secondary suspension. The major failure occurred in this type of tri-mount bogie is multiple cracking in bogies at critical locations.
WAP-4 means wider alternative passenger. It is mounted on two flexi-coil bogies which rest on center pivot. Each center pivot carries 50% of the vertical load and receives transmit tractive and braking force. This type of bogies is having primary and secondary suspension. Thus, cracking of bogie frame is eliminated. The major failure occurred in this type of locomotive is frequent cracking in center pivot cross structure and the bolts in frame. WAG-7 means wider alternating current goods. It is mounted on two fabricated design which have one center pivot and four side barriers. In this, each center pivot does not carry any vertical load and transmit tractive and braking force, whereas all the vertical loads are shared by four side barriers. This type of bogies is having primary and secondary suspensions. Thus, cracking of bogie frame is eliminated. There is no crack occurred in this type of bogie. The main problem identifications are continuous vibration due to MVMT traction motor blowers. The continuous vibration are caused by MVMT motor. It is centrifugal type traction motor blower. It runs at the speed of 2910 revolution per minute. It is designed to deliver compressed air at a rate of 278 m3 per minute. The net weight of blower including motor is 490 kg. It helps in cooling traction motor. The improper welding of cross section is one of the main problem identification. If the welding of vertical plate is not proper with the top cross plate and the middle plate, then during normal running and braking abnormal vibration and noisy may be felt in the nearby areas of the center pivot. These vibrations may cause serious crack in MVMT duct repeatedly and mounting bolts of MVMT, as well as its mounting base may become loose frequently. Areas to be welded: welded of center pivot with base plate, plug welding of middle plate with base plate, welding of vertical plate with middle plate and sole bars, welding of gusset plate above the center pivot structure with vertical plates and middle plates on all four sides, welding of top plate with vertical plate and main sole bar, plug welding of top plate with gussets. The upward impact from bogie is one of the problem identification. The impact due to irregularity in the rail tracks causes upward impact force through the bolster frame of the bogies to the center pivot cross structure. Thus, it makes center pivot cross structure vulnerable to cracking. The impact force is unavoidable and affects the center pivot cross structure of WAP-4 LOCO, even though the primary as well as the secondary suspensions are provided. The components used are base plate, middle plate, center pivot, vertical plate, gusset plate, strengthening plate, and top plate. The material used in this center pivot cross structure are IS 2062 grade C, and the chemical properties and the mechanical properties are shown here.
This is the comparison between the existing structure and the proposed structure. In existing structure, there are 2 gusset plates used, each of 12 mm thickness. In proposed structure, there are 5 gusset plates used, which are 16 mm thick. In existing structure, we are not using the strengthening plates, but in proposed structure, we are using 2 strengthening plates. In existing structure, the base plate is 20 mm thick, and in proposed structure, the base plate is 30 mm thick. The other plates like vertical plate, middle plate, etc. are 12 mm thickness in existing structure, and in case of proposed structure, we are using it as 16 mm thick. These are the results which we got using the ANSYS 14.5. With this diagram, we could see that the maximum stress distribution is around 3.0 e power 7 and the minimum stress distribution is 12656. So we could see that the maximum stress distribution is occurred near the circumference of the center pivot in the base plate. This is the total deformation diagram in the existing structure. We could see that the deformation is not uniform all over the cross structure, which leads to the probability of cracking of the cross structure during the loading conditions. These are the results which we obtained for a stress distribution in proposed structure. In this diagram, we could see that the maximum stress distribution is around 1.85 into 10 power 7 and the minimum distribution is 1452.3. We could see that the stress is distributed evenly all across the cross structure, and from the total deformation diagram, we could see that the deformation is uniformly distributed all over the structure, so that the cracking of the center pivot cross structure is completely reduced or eliminated. This tender notice is drawn by Southeastern Railways. This tender notice shows that the replacement of each center pivot cross structure costs more than 1.85 lakhs. Due to frequent failure of cross structure, a huge amount is spent for its replacement. By implementing our proposed model, the frequent replacement can be reduced and thus the overhauling time and expenses can be eliminated.
Thank you for watching.